All right, let's talk about that one chapter in the math textbook. You know the one. For a lot of us, it brings back some, well, let's just say intense memories. I'm talking about permutations and combinations. But today, we're going to dismantle that fear. We're going to show you that this whole dreaded topic, it's really built on just one single, surprisingly simple idea. And hey, if you've ever felt that way, you are so not alone. It's not just a feeling, it's a real thing. In fact, one of the sources for this explainer, a pretty popular math educator, puts it perfectly. They describe it as a chapter that inspires dread, not just in kids, but in teachers too. So yeah, it's famously tricky for a reason. But what if I told you there's a secret? What if this entire feared topic, with all its crazy formulas and confusing problems, what if it all boils down to one single simple idea? Seriously, what if you could solve almost any PNC problem without having to memorize a single new formula? Stick with me here. Okay, so let's dive right in and look at a classic problem from this chapter. On the surface, it looks pretty simple, but this is exactly the kind of question that can get super complicated really fast if you don't have the right way of thinking about it. So here it is. Picture a hall with 4 gates. Simple enough. Now the question is, in how many different ways can a person enter through one gate and then exit through a different gate? The key word there is different. Seems straightforward enough, right? All right, so the first instinct might be to just list everything out, right? The hard way. You could say, okay, I enter through gate 1, so I can leave through gate 2, 3, or 4. That's 3 options. Then I enter through gate 2, so I can leave through 1, 3, or 4. That's another 3. You can already see how this is getting, well, tedious. Imagine if there were 10 gates or 20. No way. There has to be a smarter way to do this. And of course there is. This is the moment we switch gears. We're moving from the messy problem to the elegant solution. Let's pull back the curtain on that one single powerful idea that unlocks not just this gate problem, but this entire topic. And here it is. It's called the fundamental principle of multiplication. Don't let the fancy name fool you. It is shockingly simple. All it says is this. If you have a big job to do and you can break it down into a series of smaller sub-jobs that happen one after the other, the total number of ways to do the whole thing is just the number of ways for the first step times the number of ways for the second, and so on. That's it. That's the whole idea. So, okay, that sounds great in theory, but how do we actually use it? Well, we're going to use a really simple but powerful technique. We'll call it the job method. And what it does is turn every one of these tricky problems into a clear step-by-step process. Let's go back to our gate problem and see how this thing works in action. Okay, let's break it down using the job method. Step 1, what's the big job we need to do? It's entering and exiting the hall. Simple. Step 2, can we break that job into smaller subjobs? Absolutely. We have entering, and then we have exiting. Step 3, let's count the ways for each subjob. How many ways are there to enter? Well, there are 4 gates, so 4 ways? Easy. Now, once you're in, how many ways are there to exit? Remember the rule? It has to be a different gate. So 1 gate is used up, leaving us with 3 ways to exit. Okay, last step. We just multiply. 4 times 3 is 12. And there you have it. That's our answer. No more making long, messy lists. No scary formulas. Just a simple, logical breakdown of the job. See how clean that is? That's the power of this method. Now, here's the really cool part. This isn't just a neat trick for the gate problem. This way of thinking, defining a job, splitting it into subjobs, and multiplying the options, this is a universal tool. You can apply it to so many different problems. Let's put it to the test on a couple of scenarios that look totally different at first. Okay, just look at how versatile this is. On the left, we've got a flag problem. The job? Create a 3-stripe flag using 6 colors with no repeats. So, subjob 1, pick a color for the top stripe. You've got 6 choices. Subjob 2, pick the middle color. You've used 1, so you have 5 choices left. Subjob 3, the bottom stripe. You've got 4 choices left. You just multiply them, 6 times 5 times 4, 120 ways. Now look at the right. Totally different problem. A true-false test with 3 questions. The job? Answer the test. Subjob 1, answer question 1. 2 options, true or false. Subjob 2, answer question 2. 2 options again. Subjob 3, same deal, 2 options. Multiply them, 2 times 2 times 2, 8 possible ways to fill out that test. See? Different problems, but the exact same simple logic. And this gets to the absolute heart of it. The secret to this whole chapter isn't about memorizing weird formulas like NPR or NCR. Forget about those for a second. The real skill, the superpower really, is learning to look at any problem and just ask yourself, what's the main job here? And what are the smaller steps, the sub-jobs I have to do in order to finish it? If you can do that, you can solve almost anything they throw at you. So I want to leave you with this final thought. Think about your daily life. When you pick out an outfit, that's a job, right? There's a sub-job for your shirt, a sub-job for your pants, another for your shoes. When you're ordering a pizza, a sub-job for the size, the crust, the toppings. How many of the choices you make every single day are just a series of these little sub-jobs, all waiting to be counted? You're navigating a world of possibilities, one simple choice at a time.